Can a black hole explode? Black holes are cosmic vacuum cleaners, massive objects so large that even light cannot leave them. Most people think that black holes do nothing but sit and devour stray gas or dust. But could black holes have a more interesting life? Can they, for example, explode? If the explosion is a sudden short-term release of a huge amount of energy, then definitely yes. And the best part is that they can explode in several interesting ways. Hawking radiation. There is one curious way of exploding black holes. The process behind this is related to the fact that black holes are not completely black, which was discovered by the famous astrophysicist Stephen Hawking in 1976. In classical physics, nothing can come out of a hole, said Samir Mathur, a physicist at Ohio State University. But Hawking discovered that using the mechanisms of quantum mechanics, the hole slowly carries its energy to infinity, emitting low-energy radiation. This is called Hawking radiation. Until a black hole sucks in new material, it will slowly lose mass by emitting Hawking radiation. However, Hawking radiation is emitted slowly. An ordinary black hole with a mass several times the mass of the Sun emits about 1 photon per year. At this rate, a typical black hole would take 10,100 years to completely evaporate. But Hawking realized that smaller black holes evaporate much faster. As the black hole gets smaller and smaller, it emits more and more radiation. In the last moments of its life, a black hole emits such a powerful stream of high-energy radiation and particles that it can be considered a bomb. If small black holes, the size of the Earth, formed in the very early universe, they would take several billion years to evaporate, which means that these primordial black holes, if they exist, would be exploding all over the universe right now. To date, astronomers have not found any evidence of primordial black holes exploding, but they may be there. Supershining. Black holes explode in a different way. Rotating black holes, also called Kerr black holes after the New Zealand mathematician Roy Kerr, who first understood how they work, create an ergosphere around their event horizon. The ergosphere is an elongated area of space where nothing can stay in place. Everything that falls on a rotating black hole begins to rotate around it. Rotating spacetime around a black hole can also attract photons. If there are enough photons, they can be reflected from each other or from any stray particles. Sometimes the rebound causes photons to leave the ergosphere. But in other cases, the bounce causes photons to approach the black hole, where they receive energy. Then they can go back to a higher orbit, and then again to a lower one. With each repetition of the process and each journey around the black hole, the photon receives energy. This process is called superemission. If the photon finally breaks free, it will have a huge amount of energy compared to the state when it just started its journey. If enough photons are involved in this process, they can all explode simultaneously with incredible energy, turning into what is known as a black hole bomb. Although the black hole itself does not explode, this superradiance effect shows once again how strongly black holes can affect their surroundings. Wheels and jets. The most common way black holes are caused is not by their own self-destruction, but by their gravitational pull. Supermassive black holes are located in the centers of galaxies, and sometimes large clumps of matter, such as stars, pass too close. When this happens, the star is torn to shreds due to tidal effects, and this ripping process releases an explosive burst of energy. Astronomers on Earth can observe this release of energy as a short but intense burst of X-ray and gamma radiation. In addition to destroying stars, these giant black holes often collect swarms of matter that constantly circle around them in the form of giant accretion disks. Accretion disks reach temperatures of quadrillions of degrees, which makes them the brightest objects in the universe. One luminous disk can outshine more than 1 million galaxies at the same time. At maximum power, the disks wind up electric and magnetic fields, which direct part of the disk material around black holes and outwards in the form of long thin jets extending for tens of thousands of light years. Although these jets are not technically considered explosions, they are still quite intense.